So today we're going to look at how clouds form as well as different types of clouds. Now clouds consist of tiny water droplets or even ice particles that are too light to fall to earth. Now clouds will form when warm air rises. This will allow water droplets to evaporate from the surface of oceans, dams or rivers. This warm air will then cool down and condense into water droplets or ice crystals when it's cool enough. The tallest clouds will form in tropical regions like the tropopause. Now, clouds will only form precipitation if they have enough water or ice particles that can then collide and join together. So here, as the particles grow too big and heavy to be supported in the air, they will fall through the rising air currents. Now remember, precipitation can be anything from rain, hail, snow, any form of water that is being deposited onto Earth. Now the cumulonimbus and the stratus are the only clouds that are capable of producing precipitation. This is because stratus clouds are just thick enough to produce a drizzle, and cumulonimbus clouds have strong rising currents and vertical height and thickness to produce rain. Now we get different types of clouds as well, and here we can see a good representation of the different types of clouds that we get. And these clouds occur at different heights above ground. Now we're going to start with the highest clouds. Here we can see an example of the cirrostratus cloud. Now this cloud occurs very high, above 6 kilometers above the Earth's crust. Now these are thin white layers that are made up of ice crystals with a wide horizontal spread, and it often covers the whole sky. Now usually when we see this type of cloud, we know that the weather will be just fine. It will not produce any rain. Now cirrostratus clouds can be difficult to detect unless you look for the effects that they create. Now one of the most distinctive features of these clouds is the fact that they create a halo. Now this is because of the ice crystals in the cloud that refract light. Now the halo is usually about 22 degrees in radius and forms a ring around the sun or the moon. They often also cover large areas of the sky, sometimes even the entire sky, but they do not block out sunlight completely and kind of give the sky a milky or hazy look. Next, when I have a look at the cirrus clouds, and they're also above 6 kilometers above the Earth's surface. Now these are narrow wisps of clouds. They're white and made of ice crystals as well. They also bring fine weather, so they don't cause rain at all. We can see that these clouds often look like delicate brush strokes or tails that spread across the blue sky. Now these clouds are usually isolated or in small patches and does not cover the whole sky. Now although these clouds are seen in fair weather, often in a clear blue sky day, they can sometimes signal a change in the weather, especially if they start to thicken or increase in number. Then we have the cirrocumulus clouds, which are also above 6 kilometers. They are thin, white, and they're a heaped cloud with ice crystals. They also do not cause rain and just bring fine weather. But here we can see that they kind of look like tiny cotton balls, often grouped together in ripples or patterns. The cloudlets are very small and tightly packed, and they do not cast shadows on each other. So far we can see at very high altitudes, above 6 kilometers, the clouds are made up of ice crystals, and this is because the air here is very cold. Next we have the altostratus, and these clouds occur in the middle of the atmosphere. They are usually at a level of between 2 and 6 kilometers above the Earth's surface. Now, these can be thin and white, or they can be gray and thick with layers of water droplets. So, here the air temperature is a bit warmer for the ice crystals to be able to melt into water droplets. They also do not cause rain and bring fine weather. Here we can see that the clouds are uniform gray or blue-gray, covering most or all of the sky. The sun or the moon may be dimly visible through the cloud, but no halo is formed, unlike cirrostratus. There's no sharp edges or no visible structures like puffs or wisps in this sky. Then we have the altocumulus, and they are also at the medium level of 2 to 6 kilometers above the Earth's surface. These are thicker white or gray looking heaped clouds of water droplets. They also don't cause rain and bring fine weather. Now, these clouds can look like white or gray puffs, and they're often arranged in rows or layers. They can sometimes look like cotton balls of sheep's wool and often appear in a regular pattern like a field of clouds. They may particularly block the sun and cause shadows between the cloudlets, unlike the cirrocolumbus that do not cause shadows. We then also have nimbostratus, where the base can be low or above 2 kilometers, but the cloud itself can grow up to 6 kilometers. Now, these clouds are thick and dark gray layers of water droplets. They can cause a steady rain or a drizzle. They usually do not have any distinct puffs or layers and seem featureless and flat in appearance. Now, the sun or moon here is completely blocked. Not even dim glow can be seen. Here the sky looks dull, overcast, and heavy. We can then look at our clouds that are at a low level in the atmosphere, between 0 and 2 kilometers above the Earth's surface. And the first one that we're going to look at is the stratus clouds. These clouds are thin and uniform. They cause gray sheets of small water droplets with a fairly flat base. They can cause a fine drizzle. These clouds may appear foggy, especially in the early morning, and often give the sky a dull, lifeless look. They don't have any distinct features like puffs or patterns, and is usually seen as uniform, flat, gray cloud layer that covers the entire sky at some points. We then have the stratocumulus, and these are also in the low level of between 0 and 2 kilometers, and they are white and gray, partly heaped clouds made up of water droplets. They don't cause the rain and just bring fine weather. Now, they can also look like large lumpy cloud patches or rolls, and it may look like a sky full of soft gray pancakes or rolls of cotton. They often touch or merge together, creating a layer with visible gaps of blue sky. Usually, they're darker than cumulus clouds, especially at the bottom. Then we have the cumulus clouds, which also occur at a low 0 to 2 kilometers above the Earth's surface. These clouds are white with a darker, flat base and a billowy or globular upper surface. They're made up of water droplets and can be compact or have some height. They usually bring fine weather and sunshine. Here you can see why they're often described as cauliflower shaped. They can have a flat base and billowy tops. They're clearly separated from one another with blue sky in between them. Their shadows on the ground can be seen moving on sunny days. Lastly, we have the cumulonimbus, and these have a low base, but the cloud usually extends to higher levels in the atmosphere. They're usually very dense and dark gray with vertical heights and are seen as storm clouds. They form from cumulus clouds and have a billowy head or a globular head. The head can flatten as it reaches the tropopause and will then spread out in an anvil shape. They're composed of ice crystals at the highest level, and then as we move down, we see water droplets at the lower level. Now, these can cause heavy rain, snow showers, or even hail with thunder and lightning. So, now that we know our different clouds, let's have a look at tropical storms. Now, tropical storms is the collective name for a deep, low pressure system with spirals of strong air. They're also known as typhoons in the South China Sea and West Pacific Ocean. They can also be known as hurricanes in the Gulf of Mexico, the Caribbean Sea, and the west coast of Mexico. And then lastly, they can be known as cyclones in the Bay of Bengal, in the Indian Ocean, and in the northern Australia. Now, these storms develop as intense low pressure systems, often over warm tropical oceans. Now, winds will spiral rapidly around the calm central area known as the eye. The tropical storm can be as much as 800 kilometers in diameter, but winds are constant across that. They vary, with the strongest and most destructive winds being around and within the eye wall. Now, when winds cross the ocean, they can increase in strength at the eye wall. So the storms surge in a cyclone center caused by an increase in sea level due to the strong surface winds. The warm, moist air will rise and is pulled towards the center. The strong winds and the heaviest rain will occur in the eye wall. The air will then rotate outwards at the top and then move downwards. These can cause dense cirrus canopies and varying wind speeds and rain. Now, cumulonimbus clouds can form on the outer ends of the tropical storm and can grow up to 1,000 kilometers from the eye. These clouds can be as high as 15 kilometers from the ocean surface. Now, tropical storms are rated on the 5-point Saffir-Simpson scale based on wind speeds. Now, tropical storms are considered major when they reach Category 3 and have wind speeds between 111 and 129 miles, or 178 and 208 kilometers per hour. Now, Category 5 storm can deliver wind speeds of more than 157 miles, or 252 kilometers per hour. Now, the path of a hurricane can be erratic, so landfall is not easy to predict, and this makes evacuation times short.